I raised to the power I. Is it a real number or an imaginary number? Hey everyone, welcome back. If we have to guess about this number, then by the looks of it, it doesn't look like a real number. But as it turns out, it is a purely real number. Let's see how. There are two ways of solving I raised to the power I. One of my favorite method is this one. We can express every complex number a plus ib in terms of Euler's formula r into e raised to the power I theta. So I can be written as e raised to the power I into pi by 2, and using this we can very easily evaluate I raised to the power I equals to the base I can be substituted with e raised to the power I pi by 2. So it becomes e raised to the power I pi by 2 raised to the power I. The exponents will get multiplied and we will get e raised to the power I square into pi by 2. We know that I square is negative 1. So we will get I raised to the power I equals to e raised to the power negative of pi by 2. I raised to the power I is coming out to be e raised to the power negative of pi by 2. And if you look carefully, this is a real number. It does look a little bit confusing because we have read a formula where e raised to the power I theta is equals to cos theta plus I sin theta. But don't get it confused. Cos theta plus I sin theta is equals to e raised to the power I into theta. This imaginary component is very important in this equation. So I raised to the power I is coming out to be e raised to the power negative pi by 2, which is a purely real number. And if you think about it a little bit more, you will find out that this is an irrational number, which is not a topic of discussion right now. But it is a purely real number, irrational number in that. There's another way of solving the same question. That is, we can express every number, every complex number in terms of z equals to e raised to the power ln of z, because e and ln both are inverse functions of each other and they cancel out their effects. So I can write I raised to the power I also as e raised to the power ln of I raised to the power I. And we can simplify it very easily. This becomes e raised to the power of I times ln I. Now ln I might look difficult at first glance, but it is super easy to calculate. We just have to express our complex number I in this case in terms of Euler's form. So this is e raised to the power I into pi by 2. And we know ln and e are inverse of each other. They cancel out their effects. So we get I times pi by 2. And we can substitute this value out here and we will get the same result that we got before. That is I raised to the power I equals to e raised to the power negative of pi by 2, which is a real number. Right, so there are two ways of solving it. Both are almost similar, but first one is like one step shorter. I really hope you guys like the video and don't forget to subscribe the channel and share the video with your friends. Thank you very much for watching. Have a very nice time.